Okay, so we were talking about work and energy in rotational mechanics. So let me just quickly go through everything that I discussed. So for translation, we have summation W is equal to delta K, where W is defined as the line integral of force and K is equal to half mv square. For rotation, work done due to all the torques will be equal to change in rotational kinetic energy. So here I'll write work done by forces will be equal to change in translational kinetic energy, where work done by torque is given by integral of torque d theta, and the rotational kinetic energy is half I omega square. And we will have rotational kinetic energy plus change in rotational kinetic energy. Just like we have been doing it before, the two things are simply added to each other. मेरा वॉइस
एक बार रिपीट कर सकते हैं आपने अभी जो बोला? लैग हो गया था।
ट्रैक हुई थी आपकी।
So for translation, we have work done by all the forces is equal to change in translational kinetic energy. Work done by force is defined by the line integral of F and dl. Translational kinetic for rotation, summation of मेरा नेटवर्क गड़बड़ कर रहा है। हाँ मेरा नेटवर्क गड़बड़ है, रुको मैं चेंज करता हूँ। वेट फायदेमंद होएगा। हाँ भाई अब बताओ। Now tell me, I have changed the network. Is it clear now?
अभी सही है।
Yes, sir.
So work done by torque is equal to change in rotational kinetic energy. This is the rotational counterpart of the work energy theorem, where work done by torque is defined by this integral. And I told you how to take plus minus in the last class. Plus minus will simply depend on the sense of the rotation of torque and angular displacement of the object. And rotational kinetic energy is half mv square. So if you have an object which is executing both rotation and translation, then you simply add these two equations up to LHS becomes the summation of work done by forces plus the sum of work done by torque. This means that every force that the object is being subjected to, you have to find out the torque due to that particular force, and then you have to find out the work done by the torque due to that particular force, right? Although this sounds very lengthy and intimidating, but you will see later on that it actually works to our advantage. On the right hand side, we have the sum of translational kinetic energy and rotational kinetic energy. This together can be called, if rolling is taking place. So if rolling is taking place, rolling happens, then this is called the kinetic energy of rolling. Okay, दोनों का जो sum रहे. Since rolling, Pratiksha define किया था ना, rolling is defined as when the point of contact of the rotating and translating object has zero relative velocity with respect to the surface, same velocity. This is rolling. Okay. Okay. I'm going to change the slide. Please take a screenshot of this. Okay, so in the last class, we also discussed that if we take a rod like so, and if we fix it here, such that it is fixed at this point, but it is free to rotate, then as the rod rotates, we can figure out the torque on this rod due to mg. That comes out to be mg into L by 2 cosine theta. And then we can work out the work done by this torque as the rod goes from 0 to theta. And this comes out to be mg L by 2 sine theta. But L by 2 sine theta happens to be the vertical distance traveled by the center of mass. And we therefore arrive at a very profound conclusion. That is that if torque due to gravity does work, then work done by torque due to mg will always be equal to plus minus mgh. So you never have to do this calculation again. This was a one-off starting derivation that I wanted you to do, but you never have to do this calculation again. If you see a rotating object and you see that gravity is applying a torque on this object, and you see that because of this torque, the object is rotating, and you want to figure out the work done by the torque due to gravity, then this work done will simply be equal to plus minus mgh. So it will be plus, ये बिल्कुल पहले जैसा है, if COM goes down, minus COM goes up, and h is the vertical distance between the initial and final points final points of center of mass. Okay, so center of mass का vertical displacement जितना भी हुआ, that will be the h, that will be the value of h. So you never ever have to calculate work done by torque due to mg. Okay. Coming back to this, when you calculate the left hand side of this equation for a rigid body, you are going to first see whether the body is executing rotation plus translation or not. If it is executing only translation, then this is sufficient. If it is executing only translation, then this is sufficient. If it is executing only rotation, then this is what you have to do. And this must be invoked only when you are convinced that there is rotation plus translation. Okay? तो जो मैं अब बोलूंगा वो मैं केवल रोटेशन प्लस ट्रांसलेशन की बात करूंगा. But having said this, please remember that if you see only rotation, this is what you are supposed to do. Okay. So when you are applying this equation on an object, you will find that there are, supposing, n number of forces acting on the object, for which you will have to find n number of work done. All these n number of forces are capable of creating torque. Therefore, there will be n number of torques. And you have to find the work done by all the n number of torques. However, if you remember, the reason why we went, or the reason why we introduced work energy theorem, was to get rid of certain forces, which I used to call, if you remember, constraint forces. In fact, constraints उन्हीं की वजह से आते हैं, therefore they are called constraint forces. So string forces are constraint forces because there are things called string constraints, and surface forces, normal reaction, these are all constraint forces. So we went into the concept of work and energy because we saw that the work done by these objects, by these forces, becomes zero. Net force done by tension on a system is generally zero. Net force done by normal reaction on a system is generally zero. May not be zero also, but most of the time it is zero. Similarly, we will find that work done by the torque due to these forces is actually going to help us rather than create more terms for us to analyze. Now, the way that it is going to help us is this. Please take a screenshot of this. Please take a screenshot of this. Okay. So the way that this is going to help us is this. We found that generally, I'll put an exclamation mark here because you have to be careful. Although I am using the word generally, and this is what actually happens most of the questions, but you must be aware that sometimes this will not happen. Summation of work done by normal reaction is zero. Summation of work done by tension is zero. Right? We will find the same things in rotation as well. Summation of work done by torque due to normal reaction will be zero. Summation of work done by torque due to tension will be zero. Okay. बचा क्या? mg बचा, mg तो वर्क करता है, उसके लिए तो हमें मालूम ही है mgh आएगा आंसर। इसके अलावा क्या बचा? इसके अलावा बचा फ्रिक्शन। इसके अलावा क्या बचा? स्प्रिंग फोर्स। यानी हम डिस्कस कर चुके हैं जब हम वर्क एनर्जी कर रहे थे, डोंट यू रिमेम्बर अनीश? So let's say that we have a cylinder which is rolling down, an inclined plane. So the radius is r and mass is m and everything is given to us. Now I want to find the work done on this object as it reaches the bottom. So I'm going to just draw the cylinder again here. So I want to find the work done when the cylinder reaches this point, or the center of the cylinder has gone down by a distance of L, right? So cylinder was left here. This is the initial position of the cylinder, and this is the final position of the cylinder. Let's draw the forces acting on the cylinder. The forces acting on the cylinder are mg and normal reaction n. Okay, and we know that friction will be upward. Remember, we have already discussed this. Friction F. These are the three forces acting on the object. Now, please see very, very carefully. Summation of work done will be work done due to mg plus work done due to normal reaction plus work done due to friction plus work done due to torque due to mg plus work done due to torque due to normal reaction plus work done due to torque due to friction. This is the way that you should always look at the situation. तीन forces act कर रही हैं, work done के 6 terms आएंगे. Let's work out each term one by one. So work done by mg is equal to plus mgh. Okay, where I can sort of very easily work out the value of h. I'm not going to write the value of h in terms of L. I will just say that h is equal to this. Plus work done by normal reaction, which is 0. Why is it 0? It is 0 since normal reaction is perpendicular to the displacement of the center of mass. Please notice, please be very, very careful. I may sort of miss, you have to be careful. This is a work done for the translation of the thing, and this is work done for the rotation of it. So in translation, work done by normal reaction will be 0 because the normal reaction is perpendicular to the displacement. Work done by friction should be equal to minus F into L. Why? Because work done by friction is equal to friction force multiplied by, because it is constant, right? Friction force is constant. It is not varying. Work done by this friction force must be force multiplied by displacement multiplied by cosine of the angle between force and displacement, which is equal to 180. Therefore, work done by friction is equal to minus F. Work done by torque due to mg is 0. Why is it 0? Because torque of mg is 0. Why is it 0? Since my origin is center of mass. Okay, so we have already discussed this. When the object is fixed to some point, right? When the object is fixed to some point, this would mean that it is only going to rotate, right? And that fixed point must be taken as the origin for all calculations of rotation. If the object is free to move, then we will choose the center of mass as the origin about which to carry out any and all calculations of rotational mechanics. Later on, briefly, I'll tell you how to take origin at any other point. Sometimes it is useful, sometimes it is not. For the moment, we are taking the origin at the center of mass if the body is free to rotate. Therefore, the torque of mg is 0. Work done due to normal reaction ka torque is also 0, because you notice normal reaction passes the chosen origin. And again, I want to write here that torque of normal reaction is equal to 0. Torque of normal reaction is equal to 0 because the work done due to torque of normal reaction is 0 because torque of normal reaction is 0. Because normal reaction passes through my chosen origin. Okay. Now we wish to work out the work done by torque of friction. We want to work out the work done by torque of friction. So work done by torque of friction must be equal to plus minus, we'll decide what it is, into the friction torque, which is Fr, into d theta. Okay. Friction torque by integral d theta. How do we do this? Well, F is constant, R is constant. Right? So this simply becomes plus Fr theta. Why is it plus? Can anybody tell me why is it plus? Why have I dropped the negative sign? Why not minus? Why is it plus? Why is it plus?
सर टॉर्क और डी थीटा का सेम सेंस ऑफ रोटेशन है
Because torque and theta are both anti-clockwise. So this is why it will be positive. F and R are constant, so they go out of the integral. Integral d theta is. But what is theta? What is theta?
एंगुलर डिस्प्लेसमेंट
थीटा कितना है? थीटा निकालने के लिए हम एक सिंपल सा यूनिटरी मेथड सेटअप कर सकते हैं. Okay. So if the center of mass displaces by 2 pi r, okay, if the center of mass displaces by 2 pi r, तो कितने एंगल से ये सिलेंडर रोटेट कर जाए? अगर इसका सेंटर ऑफ मास 2 पाई आर से नीचे जाता है, ट्रैवल करता है, तो कितने एंगल से ये रोटेट कर जाए?
2 पाई.
इट विल रोटेट बाय. तो अगर सेंटर ऑफ मास यूनिट डिस्टेंस ट्रैवल करता है, तो ये कितने एंगल से गोल घूम जाए? 1 by r. और अगर इसका सेंटर ऑफ मास L डिस्टेंस से ट्रैवल करता है, L by R से ये गोल घूमेगा. This will be the value of theta. And if this is the value of theta, I can put it here and I can get F R into L by R, which is equal to plus Fl. So the work done by torque due to friction plus Fl. Right? And this is where we arrive at a very nice conclusion. Conclusion is that if we have an object which is rolling, then the work done by friction is zero, because work done by friction in translation is minus Fl. Work done by friction in rotation is plus Fl. Therefore, the net work done by friction is equal to zero. Summation W is equal to plus mgh. In rotational mechanics, okay, please listen to me very carefully. मैंने ये जितना नाटक किया है, of course you can take a screenshot and you can keep it for your records. You should keep it for your records. You should revise it. However, अगर हम रोटेशनल डायनेमिक्स कर रहे हैं और रोटेशनल डायनेमिक्स में हमसे किसी ने पूछा कि भाई आप बताओ इसकी वेलोसिटी क्या होगी, then the only thing that will do work, रिमेंबर हमने ये डिस्कस किया हुआ है कि अगर वेलोसिटी पूछी गई तो वर्क एनर्जी थ्योरम लगाना होता है, एक्सेलरेशन और टाइम पूछा गया तो न्यूटन्स लॉज लगाने होते हैं, वेलोसिटी और डिस्प्लेसमेंट पूछा गया तो हमें वर्क एनर्जी थ्योरम लगाना होता है। अगर किसी रोलिंग ऑब्जेक्ट के लिए मेरे को, हाँ इग्नोर कहाँ किया भाई, क्या क्या बोल रहा है, इग्नोर कहाँ किया है? आया तो लिखा ना, बोला अच्छा नहीं तो लिखा, इग्नोर कहाँ किया है? हाँ तो यहाँ पे देखो ना, प्लस Fl है ना, यहाँ पे प्लस Fl माइनस Fl, दैट इज द होल पॉइंट. Work done by friction as a force is dissipative, but work done by friction as torque is actually putting energy into the system. Work done by friction as a torque is plus Fl. Work done by friction as a force is minus Fl. So the net work done by friction is zero. So once again, please listen to me very carefully. Although this thing that I have written here is complicated, but if you have ever in front of you a question which says, in which two things pop out. Number one, the object is rolling, and number two, velocity or displacement has to be found. Moment these two things pop out in a question, please remember that work done will simply be equal to plus minus mgh, where h would be the vertical displacement of the center of mass of the object. Plus अगर नीचे गया है, minus अगर ऊपर गया. Work done by tension, work done by normal reaction, work done by friction, ये सब खत्म हो गया. Okay, but remember that this is not the absolute truth. You may get a question. I have never ever seen a question in a competitive exam where this does not happen. However, you may get a question in which this may not be true. Okay? अगर स्लिपिंग हो गई तो ये दोनों वर्क सेम नहीं रहेंगे. अगर स्लिपिंग हो गई तो कौन सा रिलेशन फॉलो नहीं होएगा? if the object is slipping, then this relation will not be followed. Okay? Then 2 pi r displacement will not correspond to a rotation of 2 pi if there is slipping, and therefore this will not happen, and therefore this will not happen, and therefore they will not cancel out. I think there is only one question in HC Verma where this happens. In a competitive exam, I have not seen any any question like this. In our paper, you may get a question, right? Very, very rare, very, very rare. So 99.99% of the questions work done will be plus minus MGH. Okay? Please take a screenshot. We'll move ahead.
सर तो
Okay.
फिर स्लिपिंग वाले केसेस में करना क्या है, मतलब कैसे
हाँ,
सॉल्व करेंगे?
वो आखिरी में डिस्कस कर. We'll discuss that in the last part of this chapter. पहले नॉन स्लिपिंग वाले केसेस का ग्रिप हमारे पास आ जाए, then we'll discuss. So next is kinetic energy of rolling. Okay, I told you that kinetic energy of rolling is kinetic energy of translation plus kinetic energy of rotation, which is equal to half mv square plus half I omega square. But if v is equal to r omega, okay, which is sometimes true, you just have to confirm whether v is equal to r omega or not. Then what I can do is I can write this as half mv square plus half I, which is equal to which is I don't want to write like this. I'll write it by I divided by r square into omega r whole square, which is equal to half m plus I upon r square v square. So this is the kinetic energy of rolling. Can anybody tell me what is the kinetic energy of rolling of cylinder? Kinetic energy of rolling of ring. Kinetic energy of rolling of hollow sphere. Kinetic energy of rolling of solid sphere. बताइए भाई क्या है? Can you work it out? हाँ, सबका निकालो. हाँ, सबका निकालो. Yes, sir. हाँ, तो ये चीजें जो है ये याद रखनी है. This is something you must remember. Unfortunately, 3 mv square by 4 mv square, इसका कितना आता है? 5/6 mv square, 7/10 mv square. हाँ, please take a screenshot of this. Okay, so I want to now complete the question. So let's say that somebody asks me, that what is velocity of cylinder at the bottom. Okay, please see long method. We have been doing this already. Summation of work is equal to work done by mg plus work done by normal reaction plus work done by friction plus work done by torque due to mg plus work done by torque due to normal reaction plus work done by torque due to friction. This will come out to be, when you calculate, it will come out to be plus mgh. Delta K is equal to kinetic energy of translation final plus kinetic energy of rotation final minus kinetic energy of translation initial minus kinetic energy of rotation initial, which I can write as kinetic energy of translation plus kinetic energy of rotation final minus kinetic energy of translation plus kinetic energy of rotation initial. हाँ, बिल्कुल सही. Right? And then I can say that, look, this is equal to half mv square plus half I omega square minus 0. And then I can say that since rolling is happening, therefore V is equal to R omega. And therefore I will place everything in this equation and I'll get the answer. The short method, which of course you are going to use, मैं long method बार बार इसलिए दिखा रहा हूँ क्योंकि हो सकता है कि कोई क्वेश्चन आ ही जाए जहाँ पे आपको long method use करना हो. Very, very careful. Very stringent set of conditions must be satisfied for short wala method. Okay? हाँ. Short method is simply plus mgh is equal to final kinetic energy minus initial kinetic energy. So V is equal to under root of 4gh by 2. Right. This is what ultimately you are going to do. But again, my word of caution, again and again, I'll caution you. 99.99% of the questions, of course, you can do it like this. कोई problem ही नहीं. एक question होएगा 100 में जिसमें कि थोड़ा सा complication आएगा. Hopefully, you'll never see that question ever. Okay, chalo. So I'm going to the next slide now, and I want to give you a question. I am going to the next slide now. Okay. Question number 1. A rough horizontal track is connected to a circular rough track of radius r as shown. Cylinder rolls with VCM is equal to V naught on the horizontal track. Find V naught if A at point P, the normal reaction between track and cylinder is 3 times weight of cylinder. So you have to find V naught such that at point P, the normal reaction between the track and the cylinder 3 times the weight of the cylinder. नहीं आर्यन, कैपिटल आर पे भी डिपेंडेंस आना चाहिए ना. नहीं शिवेन. Okay, so let me show you. So first let's apply the work energy theorem. And very simple. This is the initial point, this is the final point. So work done by the earth will be equal to minus mgr minus r. Be very, very careful now. Okay? Center of mass कितना ऊपर गया. पहले सेंटर ऑफ मास यहाँ था, अभी सेंटर ऑफ मास यहाँ है. We know that this distance is r, and we know that this distance is r. Therefore, this distance must be r minus r. So minus क्योंकि ऊपर गया है, and h is r minus r is equal to सिलेंडर है तो 3/4 v square final kinetic energy mv square minus 3/4 mv naught square. Okay, please notice that this is absolutely the same as normal work energy theorem that we used to apply. Everything is the same except for the fact that on the right hand side you have kinetic energy of rolling. Now I have written the equation. Unfortunately, there is a problem. Problem is that since the velocity of center of mass at this point I have assumed to be v, I have introduced another unknown. So I have written a single equation with two unknowns. V is unknown and V naught is unknown. So I need to find out V in order to find out V naught. And this is a very, very common thing that you are going to face. When you apply the work energy theorem, you are going to find that you end up with a single equation but two variables. If you are unlucky, three variables. तो अगर टू वेरिएबल आएगा, अगर दो वेरिएबल आएगा, तो मेरे को एक वेरिएबल को एलिमिनेट करने के लिए एक और इक्वेशन चाहिए, और वो इक्वेशन के लिए मुझे फिर से क्वेश्चन पढ़ना है और देखना है कि क्या कोई और इंफॉर्मेशन भी दिया है क्या मेरे को. So if you look carefully, then another information is given, and that is that 3 times the weight of the cylinder. So now I ask myself, what kind of motion is the center of mass executing? Well, यहाँ तो कोई प्रॉब्लम नहीं है, तो सीधे जा रहा है. लेकिन जैसे ही ये यहाँ पे आएगा, वैसे ही सेंटर ऑफ मास तो ऐसे गोल घूम जाएगा. So the center of mass is executing circular motion. So since center of mass is executing circular motion, at point P, I get normal reaction, mg, and I don't know, there is friction. I don't know वो friction ऊपर है कि नीचे, मेरे को बिल्कुल ही नहीं पता. लेकिन मेरे को ये मालूम है that n is equal to m into v square upon radius, which is r minus r. R minus r. Be very careful. ये जो मैंने रेड से सर्कल बनाया है वो सर्कल है जिसपे सेंटर ऑफ मास गोल घूम रहा है, और वो सर्कल का रेडियस r माइनस आर. दिस इज गिवन टू मी एज 3mg. So this implies that v square is equal to 3g into r minus r. आया समझ में अभी सबको? I hope it's clear. Now you substitute this value of v square here and कितना आ रहा है? आर्यन का सही आंसर आया मेरे ख्याल से 13gr minus r by 3. Circular motion, Chetal. Circular motion. Follow the pointer. Follow the pointer. इसका जो सेंटर ऑफ मास है ये पहले हॉरिजॉन्टल चलेगा फिर ऐसे गोल घूमे. सेंटर ऑफ मास हॉरिजॉन्टल चलेगा गोल घूमे. तो ये सेंटर ऑफ मास के लिए अगर मैं एफबीडी बताऊंगा, नॉर्मल रिएक्शन लग रहा है, एमजी लग रहा है, फ्रिक्शन शायद ऊपर लग रहा है, हो सकता है नीचे लग रहा हो, मुझे मालूम नहीं. लेकिन चूंकि ये सर्कुलर मोशन है इसलिए ये जो डायरेक्शन है ये रेडियल डायरेक्शन हो गई और ये वाली डायरेक्शन टेंजेंशियल हो गई. और रेडियल डायरेक्शन में जो भी फोर्स होती है that is equal to mass into radial acceleration. Radial acceleration is
सर वो 30 की जगह 16 है.
आयन वाला ना.
हाँ
P, I have drawn the axis, right? Radial force must be equal to mass into radial acceleration. Radial acceleration is equal to v square by r, v square upon radius. चले आगे आगे बढ़े.
सर वो 13 की जगह 16 होगा.
अच्छा 16 है क्या? पक्का?
नहीं सर 13 ही आ रहा.
अरे यार नंबर gr minus r. चलो हो गया. Now you figure out the number. I don't. B part. If rigid body is a solid sphere, find minimum V naught so that sphere may complete a circle on the track. सर्कल कंप्लीट होने की क्या कंडीशन होती थी ये हम पहले डिस्कस कर चुके हैं. बिल्कुल वही कंडीशन यहां पे भी एग्जिस्ट करेगी. एग्जैक्ट सेम कंडीशन यहां पे भी एग्जिस्ट करेगी. एक जीरो ज्यादा ऐड कर दिया मेरे ख्याल से. शौनक तू थोड़ी ना आएगा. नहीं आ रहा गलत है. हाँ सही. शौनक, तेरे को फाइनल पॉइंट कहाँ लेना है? यहाँ लेना है कि यहाँ लेना है? नीचे वाला या ऊपर वाला? शौनक, कौन सा फाइनल पॉइंट लेना है? टॉप वाला लेना है? तो ऊपर वाले पॉइंट पे क्या कंडीशन होती है? फुल सर्कल कंप्लीट करने के लिए पार्टिकल की क्या वेलोसिटी होनी चाहिए?
रूट आर जी।
तो यहाँ पे जो इसकी वेलोसिटी होनी चाहिए वो होनी चाहिए रूट ऑफ r minus r into g. Right? Remember this. The radius of the circle is r minus r. And how high did it go? ये कितना distance है? हाँ. So work energy. Please follow my steps carefully. नहीं Anish, you cannot add two quantities having different units. Work energy minus mg 2r minus r is equal to, I will just go back for my reference क्योंकि मुझे कभी याद नहीं रहता. आपको याद रहना चाहिए, मुझे नहीं याद रहता. 7/10 mvf square minus 7/10 mv naught square. लेकिन vf की वैल्यू तो मुझे मालूम है, तो ये हो जाएगा माइनस एम जी टू आर माइनस आर 7/10 mg r minus r minus 7/10 mv naught square. कैंसिल हो जाएगा. -20g r minus r 7g r minus r. हाँ, -7 v naught square. V naught is equal to root of 27g r minus r. Okay, please take a screenshot. Going to the next screen. So a holosphere is based from the top of a fixed rough hemisphere. Find theta where it will leave the hemisphere. Right now we have done question like this. So this will also be done in the exact same way, except of course we are considering rolling as well. नहीं नहीं, everything remains the same except the kinetic energy वाला term, it changes. Very good term. बाकी के लिए भी निकाल दे तरुण, रिंग से लेके सॉलिड स्फीयर तक. हाँ शिव, please find for all other objects, all the three other objects, ring, cylinder, and solid sphere. नहीं प्रतीक्षा, गड़बड़ है. सॉलिड स्फीयर नहीं है, ये हॉलो स्फीयर है. हाँ, वो भी निकालना ही है, खैर उसका सही निकालना. वेरी गुड शिव, ये सिलेंडर का है. ट्रक का है ना, ये किसका है ये? हाँ सही. हाँ है, रिंग का पाई कहाँ से आ गया भाई? अच्छा अच्छा अच्छा, सॉरी. मैं कॉज इनवर्स में इतना आदत हो गई है कि मैं भूल ही गया था कि हाँ सही है, सही है, सही है. हाँ हाँ, वरुण, सिलेंडर का सही है, रिंग का सही है, सॉलिड स्फीयर का भी सही है, सब सही है. हाँ Shiva. Once you worked out for one, then every other is just about changing the value of moment of inertia, right? हाँ बिल्कुल सही. Yes. So first we apply the work energy theorem. The center of mass has gone from this level to this level. So the work energy gives me plus this time mg r plus r into 1 minus cosine theta. बिल्कुल सही. यस यस. अब ये r प्लस r कैसे आया? ये वाली जो डिस्टेंस है ये r प्लस r है. हाँ प्रतीक्षा बिल्कुल सही. और ये वाली डिस्टेंस इज r प्लस r cosine theta because the hypotenuse of this right angle triangle is r plus r. Therefore, the work done will be this much. This will be equal to the final kinetic energy. Going back to this 5 by 6. 5 by 6 mv square minus 0. Again, we end up with one equation and two unknowns because v is unknown and theta is unknown. But then I notice that the motion of the center of mass is circular. And what I can do at this point is I can then draw the tangential axis and the radial axis. And then I can draw the force acting on it, mg. बिल्कुल सही. So from the circular motion of center of mass, please notice that center of mass अगर circle में move कर रहा है तो बिल्कुल वही सारे laws apply होंगे जो पहले होते थे. We get mg cosine theta is equal to mv square upon r plus r. V square is equal to r plus r into g cosine theta. Therefore, I get mgr plus r 1 minus cosine theta 5 by 6 r plus r mg cosine theta. 6 minus 6 cosine theta is equal to 5. मैंने क्या गलत किया?
सर सही है.
वो 5 cos theta होगा.
हाँ?
5 cos theta.
5 cos theta.
मैं डर गया था. 11 cosine theta. Cosine theta is equal to 6 by 11. Theta is equal to cosine. Right, and you can repeat this for cylinder and ring and hollow तो हो गया ना, solid sphere. Okay, next question. So you'll notice that all the questions are basically repetitions of what we've already done. LOCM क्या होता है? अच्छा, लॉ ऑफ कंजर्वेशन ऑफ, हाँ बिल्कुल। सरफेस ऑफ, देखो जहां पे वो रोल कर रहा है ना वो सब रफ, जहां पे वो रोल कर रहा है वो सब रफ। बस वेज और सरफेस के बीच, वेज और हॉरिजॉन्टल सरफेस स्मूथ, वहां फ्रिक्शन जीरो। नहीं बे, वेज फिक्स नहीं है तभी तो, नहीं तो फिर आंसर माइनस एम बी एच सीधा नहीं हो जाएगा वो तो। क्या 10/7 √10/7 बी एच। नहीं यार, तभी मूवेबल है ना वो, एम कैपिटल एम पे डिपेंड करेगा। बिल्कुल वही करना है जो पहले किया था, एक्सेप्ट काइनेटिक एनर्जी वाला टर्म चेंज हो जाएगा बस। माइनस mgr-r is equal to final kinetic energy, which is half mv square plus half mv square minus initial kinetic energy 7/10 mv square mv naught। ये कैसे आया, क्या हुआ यहाँ पे? Now, what you have to understand further, अब मैं और आगे बढ़ रहा हूँ, when you find that rotation and translation is going on, then this is true. But if at a point this becomes zero, so kinetic energy of rotation, let's say, becomes zero, the kinetic energy of translation may or may not become zero. And this may happen the other way around as well. The kinetic energy of translation may become zero, but the kinetic energy of rotation may or may not become zero. How do I conclude this? How do I know कौन सा जीरो होने वाला है, कौन सा नहीं जीरो होने वाला है? In this question, when we say that the sphere is at the highest point, what do we mean? We mean that the sphere is here. Center of mass is यहाँ पे. Relative to the wedge, अगर स्फीयर की कोई वेलोसिटी यहाँ पे रहेगी तो ये और ऊपर चला जाए, which we don't want, because we want this point to be the highest point. So for this point to be the highest point, शौनक मेरी पूरी स्क्रीन खा गया था. For this point to be the highest point, the velocity of the solid sphere according to this guy standing on the wedge must be zero. But if the person who is observing the wedge himself has a velocity, then with respect to the ground, we will see that the center of mass of the sphere also has a velocity. Okay. Now, that translation has got nothing to do with the rolling of the object, and therefore that kinetic energy will survive. That kinetic energy will be present without the kinetic energy of rolling. Kinetic energy of rotation क्यों खत्म हो गई? क्योंकि kinetic energy of translation खत्म हो गया इस आदमी के रिस्पेक्ट में, ग्राउंड के रिस्पेक्ट में. therefore इस ऑब्जेक्ट के सेंटर ऑफ मास की एग्जैक्टली वही वेलोसिटी होनी चाहिए जो वेज की वेलोसिटी. therefore this comes. And the second equation, of course, will come from the conservation of momentum, which is very, very easy. We get
सर
mv naught.
वापस से एक बार बताओ देते हैं रोलिंग क्यों खत्म हुआ?
हाँ, और फिर से बता, एक मिनट. mv naught is equal to m plus m into v. Okay, now you take this value of v, put it here, and find the value of v. Okay, so let me explain this again. In fact, let me explain this again and let me give you another question. So okay, please take a screenshot of this question. I'll go back to the previous question. So as this object, okay, let me just go here. So as this object starts to climb the wedge, right, we know that friction will be like this, up the incline. Because of this, the rotation of the object, which was like this, will slow down. Omega will decrease. Okay. And because of the fact that there is an mg also acting down, v will also decrease. But this omega and v are angular velocity and velocity of center of mass as seen by observer on the wedge. But because of the normal reaction which is being applied by the sphere on the wedge, जिसका horizontal component है, the wedge itself is accelerating in this direction. It is picking up a velocity in this direction. This means that this sphere is also picking up a velocity in this direction. And when the sphere reaches the top, the velocity of the sphere, according to this guy, will be 0 and omega will be 0. But since the wedge is moving in this direction, according to the observer on the ground, because the sphere has to remain in contact with the wedge, the center of mass of the sphere will be moving with the same velocity as the wedge at the topmost point. ऐसा समझ में आया? ये जो वेलोसिटी है और ये जो ओमेगा है ये अलग है, ये जो वेलोसिटी है ये अलग है. This is due to the fact that the sphere is on the wedge. वो मैं बार बार एग्जांपल नहीं देता हूँ, आपको याद है ये ट्रेन में जो आदमी है, ट्रेन में आदमी उठ के 5 किलोमीटर पर आवर से आगे चलने लग गया, ट्रेन की वेलोसिटी 50 किलोमीटर पर आवर है, तो हमको ग्राउंड पे 55 दिखाई देगा. पीछे चलने लग गया तो हमको 45 दिखाई देगा. लेकिन ट्रेन के अंदर जो बैठा है उसको तो 5 आगे और 5 पीछे ही दिखाई देगा. So when this sphere reaches the topmost point and it is in contact with the wedge, it is just like that train wala scenario. With respect to the train, with respect to the observer on the wedge, the sphere has completely stopped moving. But with respect to the ground, it still has some translational motion. This translation motion that the sphere has, it cannot be responsible for angular motion. That means that this velocity cannot in any way be related to omega of the object. ठीक है?
सर अगर स्फीयर के टॉप मोस्ट पॉइंट पहुंचने से पहले ही वेज अगर पलट जाता तो
अगर वेज क्या हो जाए?
दूसरी साइड पलट जाए।
पलट जाए
हाँ
तो तब तो भैया तो टूट जाएगा, वो खत्म हो गई कहानी, फिर तो बहुत कॉम्प्लिकेटेड हो जाएगा। अब ये जो क्वेश्चन मैंने दिया ये इसका उल्टा है, क्योंकि जब वो स्मूथ साइड में आ जाएगा सिलेंडर तो क्या खत्म हो जाएगा उसके ऊपर? जब ये सिलेंडर स्मूथ साइड में आ जाएगा तो क्या खत्म हो जाएगा? फ्रिक्शन खत्म हो जाएगा। फ्रिक्शन खत्म हो जाएगा तो क्या खत्म हो जाएगा? फ्रिक्शन खत्म हो जाएगा तो क्या खत्म हो जाएगा? सिलेंडर के ऊपर फ्रिक्शन खत्म हो जाएगा तो क्या खत्म हो जाएगा? भाई सिलेंडर के ऊपर तीन फोर्सेस लग रहे हैं ना, एन, एमजी और फ्रिक्शन। टॉर्क कौन प्रोवाइड कर रहा है?
रोटेशन खत्म हो जाएगा,
हाँ, तो रोटेशन नहीं खत्म होगा, टॉर्क खत्म हो जाएगा।
और खत्म हो जाएगा।
जब टॉर्क खत्म हो गया तो चेंज इन रोटेशनल काइनेटिक एनर्जी खत्म हो जाएगी। दैट मींस दैट द रोटेशनल काइनेटिक एनर्जी विल नाउ रिमेन अनचेंज्ड। जब इस पॉइंट से मैं सिलेंडर को रोल कर रहा हूं तो जैसे जैसे सिलेंडर नीचे आ रहा है, इट इज पिकिंग अप बोथ ट्रांसलेशनल काइनेटिक एनर्जी एंड रोटेशनल काइनेटिक एनर्जी। It is picking up translational kinetic energy because of the fact that mg and friction forces are acting on it. It is picking up rotational kinetic energy because of the fact that friction is applying a torque on it. But the moment it crosses over to the smooth side, friction disappears, therefore torque disappears. Therefore now no rotational kinetic energy change can take place. That is what I am trying to show you here. So it is only because of this that this may happen. Only because of this that this may happen. So if this suddenly becomes zero, then this also becomes zero. But remember what I'm writing, delta kr becomes zero. That means change in kinetic energy of rotation becomes zero. Rotation kinetic energy itself does not become zero. तो जब ये ऑब्जेक्ट हाईएस्ट पॉइंट पे पहुंचेगा तब ये रोटेट करता रहेगा उस ओमेगा से, जिस ओमेगा से ये यहाँ पे रोटेट कर रहा है। ये ओमेगा और ये ओमेगा सेम रहेंगे। तो सेम हाइट पे जाना चाहिए, ज्यादा हाइट पे जाना चाहिए या कम हाइट पे जाना चाहिए? सेम हाइट पे जाना चाहिए, कम हाइट पे जाना चाहिए या ज्यादा हाइट पे जाना चाहिए?
ज्यादा।
Again, see, again, try to follow what I'm saying. Try to follow what I'm saying. When the cylinder reaches the bottom point, then the gravitational potential energy has been converted in part into translational kinetic energy and into rotational kinetic energy. Now, when it starts going up the smooth part, the energy again starts to convert into potential energy, but this time the rotational kinetic energy cannot change. तो अगर इसके पास पोटेंशियल एनर्जी 100 जूल्स थी पहले, उसमें सपोजिंग 60 जूल्स ट्रांसलेशनल काइनेटिक एनर्जी और 40 जूल्स रोटेशनल काइनेटिक एनर्जी, तो जब ये स्मूथ पार्ट पे चढ़ना शुरू करेगा तो केवल ट्रांसलेशनल एनर्जी पोटेंशियल एनर्जी में कन्वर्ट हो सकती है, रोटेशनल एनर्जी कन्वर्ट नहीं होएगी क्योंकि वहां पे अब इसके ऊपर टॉर्क नहीं लगा। तो ये कम हाइट पे जाएगा, सेम हाइट पे जाएगा या ज्यादा हाइट पे जाएगा। अगर इसके पास ओरिजिनल पोटेंशियल एनर्जी 100 जूल्स थी, इसमें 60 ट्रांसलेशनल है और 40 रोटेशनल है बॉटम मोस्ट पॉइंट पे। अब जब ये वापस ऊपर जाना शुरू करेगा तो केवल ट्रांसलेशनल एनर्जी वापस पोटेंशियल एनर्जी में कन्वर्ट हो सकती है, रोटेशनल कन्वर्ट नहीं होएगी। So what should be the answer?
कम हाइट पे जाएगा।
नहीं, कम हाइट पे जाएगा, कितने हाइट पे जाएगा? You have to tell me h dash. You have to work it out. है नहीं, यहाँ पे इसकी काइनेटिक एनर्जी क्या होगी? mgh is equal to kinetic energy of translation plus kinetic energy of rotation. But we know that for a cylinder this is equal to 3/4 mv square. So mgh
सर h माइनस r नहीं होगा?
हाँ h minus r, मैं h लेके चल रहा हूँ, फिर बाद में इसको एडजस्ट कर। So 4/3 mgh is equal to mv square. This implies that the kinetic energy of translation, which is half mv square, is equal to 2/3 mgh, and only this is available for conversion back into potential energy. So 2/3 mgh should be equal to mgh dash. H dash will be equal to 2/3 or h minus r. आया समझ में मैंने क्या किया? I have said that look, as it comes down, the height h, as the center of mass comes down, a height h or h minus r, whatever it is. This potential energy is distributed or is equal to the sum of kinetic energy of translation and the kinetic energy of rotation, which is equal to 3/4 mv square. Therefore, the value of mv square is equal to 4/3 mgh. Now I know that the kinetic energy of translation is given by half mv square, and I just put in the value of mv square in this, and I get 2/3 mgh. That means that out of this mgh, 2/3 is kinetic energy of translation, 1/3 is kinetic energy of rotation. So when the object starts going up the smooth side, the rotational kinetic energy now does not have any role to play. It will not change, and therefore no energy transaction can take place. So the potential energy that the object will gain as it goes up must only be converted from the translational kinetic energy part. And since the translational kinetic energy part is 2/3 of the rotational of the total energy, therefore it will only go up to 2/3 of the initial height. जब ये ऊपर जाएगा तो ऊपर जाते 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 गोल 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 घूमता जा रहा है. टॉप मोस्ट पॉइंट पे इसकी वेलोसिटी 0 हो गई सेंटर ऑफ मास की, लेकिन वो गोल 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 घूम रहा है. एंड एग्जैक्टली उसी एंगुलर वेलोसिटी से घूम रहा है जिस एंगुलर वेलोसिटी पे स्मूथ पार्ट पे आया था. बिकॉज स्मूथ पार्ट पे आते ही टॉर्क 0 हो गया, और अगर टॉर्क नहीं है तो एंगुलर एक्सीलरेशन नहीं है. एंगुलर एक्सीलरेशन नहीं है तो एंगुलर वेलोसिटीज की चेंज नहीं हो सकती. Okay, चलो I'll stop here.
तो मुझे पहली क्वेश्चन नहीं समझ आई.
कौन सी वाली?
पहली क्वेश्चन mg
वर्क एनर्जी थ्योरम सीधा लगाया ना मैंने. वर्क एनर्जी थ्योरम mgh, यहाँ पे h में अज्यूम कर रहा हूँ इज द डिस्टेंस ट्रैवल्ड बाय द सेंटर ऑफ मास ऑफ द ऑब्जेक्ट. मतलब कि ये डिस्टेंस में h अज्यूम कर रहा हूँ. और फिर इसका सेंटर ऑफ मास कितना ऊपर जाएगा. नथिंग बट द वर्क एनर्जी थ्योरम. सेंटर ऑफ मास कितना नीचे आया इज इक्वल टू फाइनल काइनेटिक एनर्जी माइनस इनिशियल काइनेटिक. अभी आया समझ में?
तो ट्रांसलेशन में भी फाइनल काइनेटिक एनर्जी नहीं है.
क्या है ट्रांसलेशन में?
ट्रांसलेशनल की फाइनल काइनेटिक एनर्जी.
ट्रांसलेशनल की फाइनल काइनेटिक एनर्जी क्या बोल रहा है? नहीं समझ में आ रहा. हमने यहाँ पे डिसाइड किया था ना कि कहाँ पे डिसाइड किया था. मैंने सिर्फ बोला था, मैंने लिखा नहीं था. ये रहा, ये आया था समझ में.
हाँ सर.
ये जो शॉर्ट मेथड मैंने किया, क्या किया मैंने?
हाँ सर ठीक है. अब समझ.
मेथड यहाँ किया है, एग्जैक्टली वही चीज यहाँ करी है. बस यहाँ पे वो इंस्टेड ऑफ बीइंग अ स्ट्रेट लाइन जिससे नीचे आ रहा है कर्व है, लेकिन हमें मालूम है कि वर्क डन बाय ग्रेविटी डज नॉट डिपेंड ऑन द पाथ.
हाँ सर.
चलो भाई ठीक है. I'll see you in the next class. इसके बाद कोई क्लास नहीं है ना. ठीक है, कर देना. चलो बाय बाय. बाय बाय.
थैंक यू सर.